Hello and welcome to my channel. In this video I will be covering level 2 questions starting from question number 34. So here question number 34 says that we have to find the greatest 5-digit number which is exactly divisible by 9 and 13. Greatest 5-digit number which is exactly divisible by 9 and 13. So let's solve this. The greatest 5-digit number is 99,999. This is the greatest 5-digit number. So we need to find out a number which is not only greatest 5-digit but also it is completely divisible by 9 and 13. So this number 99,999 is exactly divisible by 9 here, but is not divisible by 13. We need to find out such number which is divisible by both 9 and 13. So for that, let us find out the LCM of 9 and 13. Here we know that 13 is a prime number, so there is no common between 9 and 13. Thus, the LCM will be here 9 multiplied by 13, which is 117. The next step is we need to divide this number 99,999 by 117 to get the remainder R. So if we will divide 99,999 by 117, then we will get 854 as quotient and 81 as remainder. So using this method we can check it. Dividend is equals to divisor multiplied by quotient and plus remainder here. So we have found it, the remainder R, which is equals to 81. The next step to solve this question is, now we need to subtract 81 remainder from this largest number, which will be here 99,999 minus 81. Here it will come 99,918. Now we can say that this is the greatest number which is completely divisible by 9 and 13 both. Next question, question number 35. Here we need to find out the multiplicative inverse of the given terms. 35. The term is a minus 1 by a, and we need to find out the multiplicative inverse of this term. So before we find out the multiplicative inverse, let us first solve this into the simplest form. We have a minus 1 by a. So here we can take the LCM of it. We will get here a, and it will become a square minus 1. So this is the simplest form. We cannot define it more further. So from here we will find out multiplicative inverse of this number. So to find the multiplicative inverse of any number, we need to find the reciprocal of it. So if we will do the reciprocal of this term a square minus 1 by a, then it will be equal to a by a square minus 1. That is, the denominator will comes into numerator and the numerator will goes into the denominator. Thus we can say that the multiplicative inverse of a minus 1 by a is equals to a divided by a square minus 1. The next question, question number 36. It says that if a number 2, 3, 4, 5, p, 6, 0 and q is exactly divisible by 3 and 5, then what will be the maximum value of P plus Q Let's solve this. We have given here the number 2, 3, 4, 5, P, 6, 0 and Q. And it is given that this is divisible by 3 and 5 both. So here we need to remember the divisibility rule of 3 and 5. Divisibility rule of 5 says that a number is divisible by 5 if and only if the unit digit of that number is either equal to 0 or equal to 5. So here we have to find the maximum value of P plus Q. So we can say let Q is equals to 5, so that the whole number is divisible by 5. Using this, we have already found the value of Q, which is equals to 5. Now the divisibility rule of 3 says that a number is divisible by 3 if and only if the sum of its digits is also divisible by 3. So here we have 2 plus 3 plus 4 plus 5 plus P plus 6 plus 0 plus 5. We have put Q equal 5. So when we will calculate this, we will get here 25 plus P. From here we can find the value of P. We need to find out a number which is greater than 25 and is divisible by 3. So the numbers which are greater than 25 and are divisible by 3 are 27, 30 and 33. So for 27 we need to put the value of P equal 2. For 30 we need to put the value of P equal 5, and for 33 we need to put the value of P equal 8. As we know, according to question, we have to find the maximum value of P plus Q. So let's say that the value of P is equals to 8. The next number which is greater than 25 and is divisible by 3 is here 36. But for that we need to add here 11 in 25 to make the value 36. In that case, we will get the value of P equal 11, which is in 2-digit number. So here we need to find out the value of P, which is only 1-digit number. So we can say that the maximum value of P will be here 8. Now we will find the sum of P plus Q, which will be equal to 8 plus 5, which is 13. Moving on to the next question, question number 37. In this we have to find out the absolute value of the given terms. 37. The terms are modulus of x minus 2 plus modulus of x plus 2. And the value of x is given here. X is greater than 0 and is less than 2. So here we can say that if x is greater than 0 and less than 2, that it must be equal to 1 here. So let us put the value of x equal 1 and solve these terms. We have here mod of 1 minus 2 plus mod of 1 plus 2. After solving it, we will get here mod of minus 1 plus mod of 3. Mod of minus 1 will turns into 1, and mod of a positive number is always equals to that number, so it's 3 here. We have get the value equal to 4. Now we will calculate the absolute value of 4. To calculate the absolute value, we need to put mod in 4. So we all know that mod of any positive number is equals to that number only. So the answer of this question is also 4, and the absolute value of this term mod of x minus 2 plus mod of x plus 2, where the value of x is less than 2 and greater than 0, is equals to 4. It says that if the value of k is greater than or equal to 1 and is less than or equal to 25, then how many prime numbers are there in the form of 6k plus 1? So one by one we will put the value of k and know all the numbers, and then we will check out which of them are prime. This type of question we have already discussed in a level 1. So let us solve this. 6k plus 1. So when we will put the value of k as 1, we will get 7 here. If we will put the value of k as 2, then we will get 13. If we will put the value of k as 3, we will get here 19. the value of k is equals to 4, then the term will be 25. Here we can see that at every interval there is a difference of 6 digits. So the rest of the value we can find out adding 6 in it, which will be, if we will add 6 in 25, we will get the next value 31, and another value is 37, 43, 49, 55, 61, 67, 73, 79, 85, 91, 97, 103, 109, 115, 121, 127, 133, 139, 145, and lastly 151. If we will put the value of k equal 25, then we will get here 151. Now we will find all the prime numbers here. So we have prime number as 7, 13, 19, 31, 37, 43, 61, 67, 73, 79, 97, 103, 109, 127, 139, and 151. So altogether we have 16 such prime numbers. The answer of this question is also 16. We have 16 prime numbers in a form of 6k plus 1, for which the value of k lies between 1 to 25. Next question we have question number 39. It says that we have here 4 variables a, b, c, and d. All are 4 positive real numbers such that the sum of a plus b plus c is equals to even number, and the sum of b plus c plus d is equals to odd number. Then we need to find out what will be a square minus d square. Either it is odd, even, prime, or odd and even both. Before we will solve this question, we need to discuss some properties of odd and even numbers. Properties of odd and even number. Let us say O for odd and E for even. Now in terms of addition we have, if we will add two odd numbers, then we will get here even number. If we will add one odd plus one even, then we will get here odd number. If we will add even plus even, then we will get here even as a result. If we will add even plus odd, then we will get here odd as result. In terms of multiplication, we have rules. If we will multiply two even numbers, then we will get result as an even number, and if we will multiply even and odd, then we will get even as a number. Again, if we will multiply odd and even, then we will get here even as a result. And lastly, if we will multiply two odd numbers, then we will get odd as a result. So before solving this question, we need to keep all these rules in mind. And for subtraction, the rules are same as in addition. It is also applicable for subtraction. So in this question, it is given that the sum of ABC is equals to even and the sum of BCD is equals to odd number. So if we will subtract these two equations, that is A plus B plus C, subtract here B plus C plus D, then what will we get here? The subtraction of even and odd is always odd. So whatever the result will be here, we will get an odd number. After solving this, we will get A plus B plus C and minus B minus C minus D after removing the brackets. and here B and B will be cancelled and C will also be cancelled, and we will get here A minus D, and we know that A minus D is odd. Now when solving this equation and this equation, we have get that A minus D is equals to odd. So if the subtraction of two number is equals to odd, then we have here two cases. Either we have A equal odd and D equal even, or A equal even and D equal odd. So from this we can see that the addition of odd and even is also odd here. Thus A plus D is also odd. Now we have to find here A square minus D square. It will be equal to A plus D and A minus D. So we have here A as odd So we have here A plus D as odd and A minus D as odd. And we know that the multiplication of two odd number is equals to odd number. So whatever the value of A square minus D square will be, it will be an odd value. So the answer of this question is also odd. The next question we have question number 40. It says that Mukesh has bought 3 apples, 5 bananas, say B, 7 custard apples, say C, for certain amount which is even. Then we need to find out the cost of apple, bananas and custard apple separately. The total cost of all these fruits is equals to even number. Let the cost of apple be, say A, B, X. Cost of bananas be Y, and cost of custard be Z. So he had bought 3 apples, 5 bananas and 7 custard apples. So we can say that 3x plus 5y plus 7z is equals to an even number, which is already given in the question. Now according to the properties of odd and even number, we can say that the sum of 3 numbers are equal to even number if and only if the number is odd, or even, then it can be even, or it will be all together even, then we have even number. So these are the two possibilities to be an even number. For this we have given options here. The first option is 5, 7 and 9. The second option is 9, 8 and 6. The third option is 2, 4 and 5. And the last option D is 9, 10 and 11. So to be the sum of all the rupees equal even, we have two possible options. Either all of 3 will be even, or any 2 of them will be odd and 1 will be even. So in the first option we can see that we have 5, 7, 9 and all of 3 are odd. So this option is not correct option. In option B we can say that we have 2 evens and 1 odd, which is also not true. In option C we have again 2 even numbers and 1 odd number. This is also not true. In option D we have 2 odd numbers and 1 even number 10. Thus we can say that we have the correct option as option D, that is 9, 10 and 11. The next question we have question number 41. Question number 41 says that in a class there are 72 boys and 64 girls. If class is to be divided into least number of groups such that each group contain either only boys or only girls, then how many groups will be formed? So here we need to find out the least number of group will be formed. What is that least number? Let us solve this question. Total numbers of students in the class we have is equals to 72 plus 64, which is equals to 136. Each group should contain either a boy or a girl. Then for that we need to find out the HCF of 72 and 64. If we will find out the HCF, we will get here 8 as HCF. The next step is we need to divide the number of students by HCF given here. So we have total number of students as 136, and if we will divide it by 8, then we will get here 17, which is equals to total number of group formed. Or we can say that least number of group formed is equals to 17. The next question is question number 42. It says that the HCF of two number obtained in the three step of division is 7. HCF of two numbers we have, which is equal to 7. The first three quotient are 2, 4 and 6. The HCF is done in division method and it is done into three steps. So we have here first three quotient. Let's say that Q1 is equals to 2, Q2 is equals to 4 and Q3 is equals to 6. Then we have to find the two numbers. What are the two numbers here? So let the two number be X and Y. Here we have X and Y. So according to question, the division is done into three steps. So we have here three steps. And we have the quotient 1 as 2, the quotient second 4 and the third quotient is 6. And the HCF of this two number is what? 7 we have. So here we know the quotient and the divisor, then we can easily find the dividend, which is equals to 42. We just need to multiply 7 multiplied by 6 is here 42. Now we have know the dividend of third step, which is divisor of second step. So here it will be 42. Now we will find the dividend of second step, which is 42 multiplied by 4, 175 here. Now 175 is dividend of the second step but is the divisor of the first step, that is it is equal to X, that is 175 here. Now easily we can find out the value of Y here, which is equal to 175 multiplied by 2, which will be here 392. Now we have already found the value of two numbers X and Y, which is 175 and 392. Using the formula dividend equal to divisor multiplied by quotient plus remainder. That's all for this video. The rest question of level 2 we will discuss in the next video. Do like and share my video if it really helped you. And don't forget to subscribe my channel. Thank you.